Hi guys, good morning. This is Dr. Sajja Suneel from Data Science Department. Today I am going to discuss controlling hardware and sensors. This was the topic which is discussed in my previous classes also, and now this was a class which is a continuation for the revision which I started earlier, and this was the part 2 which is detailing knowing about different kinds of sensors which are used in our IoT. Now enter into this particular topic. As I told you, in this, these are the different kinds of sensors which are utilized. In my previous classes, I have discussed up to this particular sensors. And now in today's class, we are going to discuss about temperature sensors with thermistor, voltage sensor, ADC to DAC, temperature humidity sensor, DHT11, motion detection sensor, wireless Bluetooth sensor, USB sensors, and embedded sensors also. Have a look, guys, how these things are going to be discussed in detail. Have a look once. Temperature sensor with thermistor. This was the sensor which is going to predict the temperature levels which are presented in environment. This is going to be used for monitoring the reacting changes in environment. You need to understand these thermistors. These are temperature sensitive resistors. These are having the capability of knowing the resistance value, which is going to change significantly as well as the temperature variant. These come into different types of packages, bed, disk, probe, etc. And these are going to use negative temperature coefficient, which are going to increase the resistance of their utilizing. Using these thermistors in IoT, which plays a major role. Thermistors are used in various IoT projects for monitoring the temperature, such as environmental monitoring systems, wearable devices like smart watches, smart appliances like refrigerators, ovens, and temperature control, and 3D printers to include the bed temperature, and connecting these thermistors to microcontrollers. These thermistors by themselves do not provide any kind of direct temperature readings. It requires a circuit to convert the resistance into voltage level. For that purpose, we need to connect with microcontroller. A common method of voltage divide circuits is thermistor with switched resistors. This is going to predict the chances of temperature across whenever it is going to change, guys. And what these microcontroller code for thermistors are. These microcontroller codes read the voltage whenever the device circuit ADC. Based on the thermistor data sheet, it is going to change the equation according to the voltage reading. The temperature data is going to specify in various purposes, displaying temperature, sending it to cloud, and based on the data, we need to analyze the temperature thresholds like tuning a fan if the temperature is too high, tuning an refrigerator if the temperature is too high, tuning an air conditioning system if the temperature is high. And coming to the next topic, which is voltage sensor. In the real world of IoT industry, voltage sensors are going to play a major role for monitoring and regulating the electrical systems. I will let you know the breakthrough. You need to understand these voltage sensors. These sensors are the devices which are going to detect and measure the electrical potentiality differences, which is voltage between 2 points in a circuit. This comes in various types. Resistive voltage devices, transformers. Resistive voltage devices, these are the simple circuits which uses resistors to create a voltage proportional to the input voltage, which are suitable for lower voltage ranges. Transformers, which are used for high voltages of AC, alternate current, which is measurable ups and downs of voltage, which is safe, accurate measurements purposes. And coming to the next, Hall effect sensors. These contactless sensors are going to detect magnetic fields, which are very common. Optocouplers, these are going to isolate the voltage AC to DC voltages for accurate measurement. And coming to the applications, in battery management, in solar power systems, in smart grid management, we are going to use this voltage sensor for knowing the battery capacity, for knowing the voltage sensor, and also in industrial automation purposes for knowing the levels in machine process, whether the machine is heated up. To prevent the damages also, these sensors are going to be very helpful. We need to integrate these voltage sensors with microcontrollers. How the things are going to be happen. Whenever we are changing the AC to a DC, analog to digital converter, we need to use these dividers by reading the microcontroller. And also transformers and Hall effect sensors are going to be additional application purposes in ADC. And optocouplers are going to provide digital upload by providing the simplification. And microcontroller code for voltage sensors. These are used for analog to digital sensor. By depending on the sensor type, the calculations will be in multiple purpose. Displaying the voltage readings on LCD by sending them to the cloud. Continuously, you can monitor the analysis report, triggering the alarms whenever you require when the voltage thresholds will be there, so that we can take care of easily. And next one, ADC to DAC. ADC and DAC. ADC, analog to digital converter, and digital to analog converter. These two plays a major role for bridging the gap between analog world and digital world microcontrollers. Now we will see how this ADC is going to convert a continuous analog signal to digital representation of microcontroller to understand. Like analog converters signals are voltage, current, temperature, light incident. These signals are going to convert it to digital representation. And the digital representation series as zeros and ones are bit conversion. And coming to the applications which are used in ADCs in IoTs are sensor data acquisition, environmental monitoring, audio processing. These are the different kinds of applications. And coming to DAC, digital to analog converter. A DAC is going to perform an opposite function of ADC. Why? Because the digitals, zeros and ones, are going to be converted from microcontroller into a analog signal, which is zeros and ones are going to convert it to analog signal with current, voltage, etc. And what are the applications? Signal control, audio generation, industrial automation. These are the different kinds of applications of DAC, digital to analog converter. In signal control, we are using actuators like motor speed as well as LEDs, all these things. Coming to audio signal generation, DAC is used for converting the audio analog to digital by using headphones. Industrial automation, which is going to be done in industries. The key considerations whenever you are utilizing these ADCs and DACs in IoT, you need to resolute the things whenever it find processing. Take an example, you are doing audio processing. You need to do a high resolution factors, ADCs and DACs, by providing a precise conversion method, sampling rate, which is going to be ADCs, and sampling rate determines how often analog signal is going to be converted into digital value. Output voltage and current range, where DAC is having a specific output with voltage or current range. And these are the key considerations which has to be kept in mind. And coming to the next one, temperature with humidity sensor DHT11. And this temperature is having a unique factor compared to previous thermistor, which is temperature sensor. And apart from thermistor, here the thermistor and humidity sensor is a combo in DHT11. Why? Because there we are only evaluating temperature readings. Here we are evaluating both temperature as well as humidity. That is the beauty of DHT11 sensor, which is a popular choice for knowing the measurement of temperature and humidity in various IoT applications due to its low cost and easy to use and compact size. And you need to understand this DHT11 digital sensor, which is meaningful output a digital signal which contains both temperature and humidity data, which uses with two main components for sensing. A capacity humidity sensor, which is going to measure an amount of moisturizer in the air by detecting the changes in capacitance, and also a thermistor, which is placed in it, measures temperatures by detecting the changes in electrical resistance. This is about two different devices which are existed in DHT11. This sensor is having a limited range, as I told you, temperature which is going to be calculated between 0 degrees to 50 degrees, humidity is going to be calculated 20 degrees to 80 degrees. These are the benefits of using DHT11. The low cost, easy to maintain, digital output, compact size. These are the benefits of using DHT11. Whenever we are connecting these DHT11 to microcontrollers, we need to use 4-pin interface. One is VCC, another one is ground, another one is data, which is bidirectional, and the other one is left with no connectivity. And these are going to be between 4 kilo ohms to 10 kilo ohms, where the data pin is going to be circulated. This is how you need to connect to microcontrollers. And coming to the next factor, here the data is going to be identified in DHT11 sensor by specifying a start signal. These sensors are going to respond whenever the data signal is containing the humidity code. Libraries such as DHT library and also for Arduino simply convocation of data coding. These are the things. What are the different kinds of applications which uses this DHT11 sensor? environmental monitoring purpose, to know about the temperature, to know about the weather predictions, data logging and control purposes will be taken care. Smart agriculture, to know about the water levels, ventilation in greenhouses, or the real-time temperature and humidity readings, and we will use this DHT11. Coming to smart homes, to adjust the thermostat settings, triggering the dehumidifiers based on temperature and humidity levels, and which improves the energy efficiency. IoT wearables, which are used to tracking the body temperatures and tracking the humidity levels. There are some limitations. Limited measurement range will be there for these both sensors. As I told you previously, 0 to 50 and some particular humidity range, 0 to 10. And coming to sampling rate, data will be 1 hertz only, which is one reading. No external power supply is going to be provided to this NHT. What are the alternatives? DHT22, which offers a wide range mechanism along with the temperature and humidity, which gives you more benefits like status detection also. And coming to BME20, which combines temperature, humidity, and also pressure sensing. These are the extensions and alternatives for DHT11 comparatively. And motion detection sensor. These motion detection sensor are going to act as eyes for your devices, which enables the precise movement within the environments. These sensors are going to play a crucial role in various applications such as security, automation, and also enhance to improve your user experience. The working principles, you need to understand what kind of motion we have to see that particular movement. Then only the function is going to detect the changes whenever functional quantities are there. Here are some operating principles. PIR, passive infrared sensors, which are very ambiguous sensors to detect the infrared radiation or the heat or which is emitted from that particular object. Whenever it was warm like a person or an animal moves in sensor field of view, that radiation pattern is going to be changed and automatically a trigger to the sensor this indoor appliances due to the sensor activity, PIR sensors. And coming to the next one, microwave sensors. Unlike PIR sensor, these are going to emit and these are going to detect high frequency microwave radiation. Any kind of movement which is detected in the zone disrupts the microwave field, which triggers the sensors. Then the ability to penetrate walls to some extent makes them suitable for outdoor applications. Coming to the next one, ultrasonic sensors. These are going to work by emitting the high frequency sound waves, which are going to detect the echoes, by reflecting the objects. These movements within the detection of zones when you compare the echo patterns. And coming to video motion detection, the video leverages which captures by the camera the footage is going to be analyzed frame by frame, difference by difference with the detection motion. This thing can be easily identified and also supports the data at the time of video composition, guys. And compared to the other sensor, these are the different applications which are using this. And coming to the things, we need to choose a particular sensor for your particular need. At that time, you need to know about what kind of environment it was. Either PIR sensors are going to be used in indoor. And coming to micro sensors, which perform better at the outdoor, which should be needed for penetrating walls. Detection range has to be considered for choosing a right sensor, and sensitivity has to be maintained for choosing a right sensor. Power consumption has to be maintained for detecting a right sensor. These are the factors, and also cost, which need to be maintained for the predicting a right sensor. And coming to the integration with microcontrollers, whenever we are conducting this method with PIR sensors, which offers you a digital output where ultrasonic sensors might be useful for conditional circuits. Microcontrollers can be programmed to read a particular sensor, either in digital or analog signal. Here we need to apply algorithms to filter noise and confirm the motion detection. Trigger actions are going to be taken by based on the video motion detection and by sending alarm and recording videos. What are the different kinds of applications which are using our particular motion detection sensors? The motion detection sensors are going to serve in multitude purposes such as smart homes, triggering lights whenever a detection motion is improving the security, convenience and emergency. Coming to security system, you need to detect unauthorized entry and triggering the alarms to enhance the home security. Building home automation, turning off the lights and appliances in unused rooms for improving the energy efficiency. Automatic doors, opening doors as people approaches for hand-free accesses. Smart pet devices. You need to manage the pet activity or tracking their movements. Smart related. Tracking customers' movement patterns to optimize the store layout and also the product placement purposes also. These are the different kinds of application which detects the motion detection sensor. And coming to the next sensor, which is wireless Bluetooth sensor. In this wireless Bluetooth sensor, as I told you, in the realm of IoT, wireless Bluetooth sensor will play a vital role for creating connected and intelligent systems. And this is going to offer you a very convenient and efficient way to collect the data from sensors without hassle-free wire and simplification of development. You need to understand this wireless Bluetooth sensor. Why? Because BLE, Bluetooth Low Energy Technology, was a wireless communication. It is a power efficient version which is Bluetooth designed specifically for data transfer. It is a good balance range, typically 1 to 100 meters, which is having a good power consumption, which is suitable for battery powered sensors. Benefits of using these wired Bluetooth sensors are it is very easy for developing the things, and the scalability will be very high, and it is very cost effective, and low power consumption will be very high, and real time data will also be there. These are the mutual benefits which we are getting of using these wireless Bluetooth sensor, guys. And next, the types of wireless Bluetooth sensors. The types of wireless Bluetooth sensors are environmental sensor. By using this environmental sensor, you are going to check the parameters like temperature, humidity, pressure, air quality. And the next one is motion sensor. By using this motion sensor, you are going to detect the motion by using PIR, infrared, passive infrared, or accelerometers. Wearable sensor integrated into wearables like smartwatches, fitness tracker to monitor the heart rate, to monitor the activity levels, to monitor other psychological data. SS tracking sensor used to track the location of the status of the objects. We are going to use these types of sensors in our wireless Bluetooth sensors. And what are the applications which are using wireless Bluetooth sensors? Are smart homes, which are used for monitoring the temperature, humidity, and occupancy, which is done in that smart home. And smart buildings to track the asset performance, to optimize the energy, to automate the building and management task. Industrial automation to monitor the production lines, to detect the equipment failure, to optimize the industrial process. We require industrial automation, these Bluetooth sensors. Precision agriculture, where tracking soil moisturizer, tracking the temperature and other factors which are related to irrigation and crop management. Inventory management, you need to monitor the stock levels. You need to optimize the inventory control in warehouses and retail stores. Coming to healthcare, wireless healthcare monitoring patterns, wearable devices for vital signals and activity tracking. These are the different kinds of applications. We need to consider multiple things for using these wearable devices. You need to consider range, you need to consider security, you need to consider battery life also here. These are the three things which we need to consider. Coming to the next factor, which is level sensor. These level sensors are playing a major role for managing and monitoring the skills in substances. These are going to provide diverse application for using the effective and potential issues. Here is a breakdown how to understand these level sensors. These level sensors are going to tell you what kind of height and volume of substance was presented in that container. Is the liquid solid, granules or powder, or even in slurry also it is going to identify. This comes in various types and principles. And coming to types of level sensor, float switches, which are simple and cost effective, and these can be used and for basic control appliances. The second one is ultrasonic sensor, which emit high frequency of sound waves, and this distance of sensors are going to be calculated. And here, by using this ultrasonic sensor, non-contact measurement will be taken care with the harsh environments. These are the types of sensors. Coming to the third one, conductive level sensors, which use two or more electrodes submerged in a container. When the conductivity liquid is specific electrode, which indicates the level of sensor. Coming to the next one, pressure level sensor, which are going to be measured, which are going to be proportionally feel versatile things. And coming to the optical level sensor, which are employing the infrared lights, lasers, which are used for reflection and absorption of light to fill the levels, which can be transparent and opaque. Choosing a right level sensor, it depends on the project which you choose. You need to choose the type of substances which where the place has to be filled. Either it is liquid, either it is solid, or either it is slurry. We need to consider these factors. Next, desired accuracy is required for predicting the precision and the container material and size. also plays a major role. And environmental conditions, cost and complexity. These are the factors which need to be considered for choosing a right level sensor effectively. What are the different kinds of levels of applications which are using these level sensors in IoT? See, inventory management, smart agriculture, chemical processing, food and beverage industry, fuel management, water waste treatment. All these are the areas where applications of level sensors was existed in IoT. And coming to USB sensors in IoT, the main objective and outcomes are these things for both USB as well as embedded. In USB, it is used for gathering the data. In embedded, it is used for collecting the device performance. Coming to the outcome, we need to provide a real-time data for analysis and automation in USB sensors. And coming to embedded systems, we need to remotely monitor the controlling devices. These are used. What are the ultrasonic sensors? What these are going to do? These are going to detect and measure the distances of link to surroundings, which improves the safety factor. USB sensors. While USB sensors aren't the most common type of sensor which are used in applications, which is a common one. Here the scenarios you need to understand was these are going to connect directly to host a computer by microcontroller board based things, which is a universal serial bus which provides a direct input where various factors are established. The applications which are using USB sensors are rapid prototyping and measurement and development, data logging and monitoring, educational use cases. These are the USB sensors which are used in IoT sectors. And coming to how to limit the USB sensors. Here the limit was wired connection is required, limited mobility is there, power consumption is compared to the other sensors it was high. Why? Because it was a wired sensor. And what are the alternatives? Wireless sensors are the alternatives for the USB sensors. Microcontroller shields are the alternatives for these USB sensors which are utilized in current IoT industry. Now we will go for embedded sensors. These are the sensors which acts as a backbone for data collection in Internet of Things. So these are the ears, eyes, and sometimes even the nose of IoT system. Why I am saying this word? Because these are the things which are constantly monitoring and measuring the physical world where the data is extracted. So we can deeply dive and take proper decision. What embedded sensors are? These are like traditional sensors which might connect to a computer via USB. These sensors are going to manipulated and integrated directly to the IoT devices. These comes in variety of sensors like temperature sensors, which are thermistors and thermocouple, pressure sensors, which are piezoelectric and capacitive, humidity sensors, resistive and capacitive, light sensors, photodiodes and photoresistors, motion sensors, accelerometers and gyroscopes, gas sensors, electrochemicals and metal oxide semiconductors. These are the different kinds of sensors which are having physical quantity like measuring the temperature, light, pressure, etc. into electrical signals. And why these embedded sensors are important in IoT? Because these are going to gather the real-time data in environment, guys. For this purpose, to monitor and control the things, to predictive maintenance, for environmental monitoring, we require these embedded systems and also for user interaction, guys. These are the important things which are done by the embedded system. What are the benefits which you are getting? Manipulation, low power consumption, easy to use, and variety of options are there in these embedded systems. Miniature, low power consumption, easy of use, and variety of options we are having in embedded sensors. And next sensor was integration with microcontroller. How these embedded boards are controlled. These are going to read the electrical signals into sensors, and these are going to communicate with other devices with the help of these things. You need to choose by measuring the things, you need to choose by measuring the accuracy, you need to choose by power consumption and environmental propositions. And coming to the examples which are using the embedded systems are smart thermostats, wearable fitness trackers, smart agriculture systems, smart homes, industrial IoT. These are the best examples which are using embedded systems in IoT. And now we will move to the last one, which is distance measurement by using this ultrasound sensor. Certainly, in the realm of IoT, ultrasonic sensors are the cost-effective and versatile solution for measuring distance without human interference. These ultrasonic sound systems, these sensors emit high-frequency sound wave, ultrasound beyond the human range towards the targeted object. Echo reflection. When the sound wave hits the object, it bounces back the echo which is received by sensor. Time measurement. These sensor measurements is traveling the object and back. ultra scan. You guys have vision at the time of medical purposes. They are tracking the things and the speed of this air approximately 343 meters per second at room temperature. And by dividing the round trip time taken of the sound and coming to that object and coming back twice the speed. What are the factors affecting? Temperature was the one which is affected. Object material was the one which is affected. Sensor angle was the one which is affected. These are the factors which are affecting the accuracy of this distance. Got it, guys? And what are the different kinds of applications which are used in IoT? Obstacle detection, smart inventory management, liquid level measurement, smart parking system, security system. These are the different kinds of applications which are using ultrasonic sensors for measuring the distance. And how we are integrating with microcontrollers. Most ultrasonic sensors have simple digital analog unit. Digital sensors or analog sensors are the things which are going to be used. And also there are popular microcontrollers which are Arduino and Raspberry. By using this Arduino, there are n number of libraries and tutorials. And coming to Raspberry, which can be programmed with Python by using ultrasensor detection. And these are the learning resources which might be helpful to you guys. And that's it. This is about controlling hardware and sensors. We'll meet in the next class by knowing about the other modules. We will revise module 4 and module 5 in detail. Got it, guys? Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.